Here we're going to be looking at number 4 from the Newton's second law problem worksheet. In this problem, a person is pushing an object up a ramp with a force of 160 newtons. The coefficient of friction between the box and the ramp is 0.3. We're going to find the acceleration of the box, and we're going to find the normal force along the way. Now we need to find the normal force in order to find the acceleration, because in order to solve for friction, we must have the normal force, because our equation for friction is the coefficient of friction times the normal force. So the first thing we're going to do is solve for the normal force by adding up our forces along the y-axis. In my positive y direction, I've got the normal force. In my negative y direction, I've got force of gravity perpendicular. Because there's no acceleration along the y-axis, it's all along the x-axis, I can say it equals 0, because ma is just 0, because there's no acceleration. From here, I know that my normal force has to equal force of gravity perpendicular. When I plug in with my equation for force of gravity perpendicular, that's the cosine of the angle, which is 35 degrees, times the mass of the object, which is 15 kilograms, multiplied by 9.8 meters per second squared. When I do that, I find that the normal force is 120.41 newtons. Now that I have that information, I can solve for what force of friction is. I know many of you like to solve for force of friction first, before just plugging it into our equation. So the equation for that is the coefficient of friction multiplied by the normal force. And our coefficient is 0.3. And we just solved for our normal force, which is 120.41 newtons. And when we plug that into our calculator, we find that our normal force is 36.1 newtons. Now we can solve for the acceleration of this block. In this problem, I said up the hill and to the left in the direction of the force of push is positive, and down the hill to the right is negative. So I'm going to take my force pushing in the positive direction, and that's force of push, minus the forces that go in the negative direction, which is force of gravity parallel and force of friction. There is an acceleration, so all of that stuff added up equals ma. So in order to solve for acceleration, I have to divide mass to the other side. So I have my force of push minus force of gravity parallel minus my force of friction, all divided by my mass, equaling A. Now I just have to plug in some numbers. Force of push is given as 160 newtons. Force of gravity parallel, we have an equation for that. That is the sine of the angle of the hill, which is 35 degrees, multiplied by the mass, which is 15 kilograms times 9.8 meters per second squared. And then I subtract friction, which we already solved, down here, which is 36.1 newtons. I divide all of that by the mass of the block, which is 15 kilograms. And that will give me the acceleration. When I plug all of that into my calculator, what I will get is 2.64 meters per second squared for the acceleration of the block. So again, first thing we did, we solved for the normal force. That way we could take our normal force and find friction using our friction equation of mu times normal force. And that gave us the information we needed to plug into our equation on the x-axis. Push minus gravity parallel minus friction equals ma. Plugged in our numbers and got our acceleration. And that's how you do problem number 4.